ವಾಯ್ಸ್ ಕೇಳಿಸ್ತು. ಹಲೋ.
ಏನ್ ಮಾಡಿ ವೇಟ್ ಮಾಡ್ರಾ ಇಲ್ಲ ಒಂದು 2 minutes ನೋಡ್ಲಾ ಕಾಲ್ ಮಾಡಿದ್ರು ಬರ್ತೀನಿ ಅಂತ ಏನ್ ಮಾಡಿ ಆನ್ ಮಾಡಿದ್ರ ರೆಕಾರ್ಡಿಂಗ್ ಆನ್ ಇನ್ನೊಬ್ರು ಬೀದರ್ ಅವ್ರ ಅಲ್ವಾ ಯು ಆರ್ ಫ್ರಮ್ ದಿಸ್ ಗುಲ್ಬರ್ಗ ಓನ್ಲಿ ಡಿಗ್ರಿ ಮುಗ್ದಿದ್ಯಾ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ ಲಾಸ್ಟ್ ನೀನೇನ್ ಎಸ್ Before starting today's class, let us revise what we have dealt yesterday. These are the 3 topics we discussed yesterday, right? First one is universe. What all we discussed in universe chapter? In this yeah. Under universe, what are the things we studied?
Journey of universe.
Sorry?
Journey of universe.
Journey of universe. How it started? Starting from which theory? Which theory? Yeah, good. Big Bang theory. After that, according to Big Bang theory, how is the universe originated? How is the universe originated? By a small? What is the word, specific word? Just think to revise from yesterday's class. Otherwise, if you are read at your own, just recall that. It is singularity. Singularity. It is this. Yeah, it has enormous amount of mass and in small volume it is highly concentrated. It exploded, giving rise to many of the planets, stars and comets, asteroids, everything. After this Big Bang theory, what we discussed? Solar system. Before moving to the Earth, we have discussed about solar system. In solar system, what is the major thing which we looked? How planets originated, then sun. First, we discussed about sun. What is the distance between Earth and sun? No. Feel free. It's about 150 million kilometer. After this, we studied each one of the planets. First planet is say me 2 points about Mercury. Good. Then after Mercury, Venus. You just recall 2 points related to Venus. Good. It is also called as Earth's twin. Does Venus have satellites? Just recheck that. Does Venus have satellites? It has no satellites. It is known as Earth's twin because of its size and similar to size and similarity with the Earth. After that, Venus, we have discussed about Earth. In Earth, what all we studied is called as blue planet. Good. After that?
It is
okay. Good. It is the only planet in our solar system where life exists. After Earth, we have Mars. Mars is famous for its red color because of presence of iron oxides. Good. And Mars has 2 famous satellites known as good. After Mars, we have Jupiter. Jupiter is one of the giant planets of our solar system. It is known as which planet? Good, gaseous planet. And it has rings and also it has satellites. How many satellites does Jupiter have? Good, 67. Which is the largest satellite? Jupiter has one largest satellite, which is known as good. It is known as Ganymede. After Jupiter, we have Saturn. Saturn is famous for its ring system. Saturn is also one of the gaseous planet. It also has a beautiful satellite known as Titan, which is second largest satellite in our solar system. After that, Uranus. Uranus is known for its color. What is the current color of Uranus? Greenish color due to presence of? No. Methane. What you said? Due to farness, its farness and due to high amount of methane in Uranus and Neptune. After Uranus, we discussed about Neptune, which is the last planet. It also appears green because of its distance and also presence of methane. This is what we studied in universe chapter, and also we met with asteroids, comets and meteoroids. You know the difference between asteroids, comets and meteoroids. Okay, that completes universe lesson. After that, we move to the Earth evolution. How many years ago the universe has started its life? How many years ago the journey of universe started? Sorry? Not 3, it is 13.8 billion years ago. After this, we discussed about formation of Earth. How is Earth formed? One theory we have discussed in evolution of Earth, which is known as that is solar nebular hypothesis. Solar nebula hypothesis. Under this theory, we studied that every planet before forming into a planet, it is just a gaseous clouds which condenses and forms what? Protoplanets. After that, it will form original planet. After this, what all we discussed in Earth evolution? We discussed some theories. Theories of formation of continents, and first one is continental. Given by Alfred Wegener in the year 1912. Continental drift theory. After this, we discussed about Panthalassa. Pangaea is a group of super continent, one single continent known as Pangaea, whereas Panthalassa is one massive oceans known as Panthalassa. After continental drift theory, we move to which theory? Plate tectonic theory is the third one. Before that? Good. Harry has seafloor spreading theory. After that, it is given by Harry S in 1960s. Third one is important theory, which is known as plate tectonic theory. Given by good. Mackenzie, Parker, and Morgan. These three have given plate tectonic theory. You mentioned the major plates and minor plates, which I told. Okay. Can you read out the major plates? Just write that in the same notes so that it will be helpful for your revision.
North American plates, African plate, Eurasian plate, Australian plate, Antarctic plate, Pacific.
Good. Can you name few minor plates? Sorry? Okay. You come up again.
Big group of plate.
No, which is between?
It is between
North American plate. Good.
Is located in Pacific plate and between North American and South American. Nazca plate, it is located between South American plate and in Pacific.
In Pacific. Okay.
Caribbean plate is located between North American plate and South American.
Oh.
And some little bit between Africa.
No, it doesn't come in Australia. Yes. So, Atlantic. Okay. Atlantic, near to Atlantic. After that?
Caribbean plate is present between plate and Eurasian.
Which is between African plate and Eurasian and Indo-Australian plate. That is also included. After that?
Indian plate is Australian.
Good.
Then Philippine plate, it's in Pacific.
Oh, it's a part of Pacific Ocean. After this, we move to the how lithosphere is formed, how atmosphere is formed, and how hydrosphere is formed. When is the life originated on Earth? When is Earth originated? After solar nebular, when nebular hypothesis, according to this, when is Earth originated? How many billion years ago? 4.6 billion years ago Earth originated. After this, when is life originated on Earth? When is life originated? Good. 3,800 million years ago. These are some facts you should know for Group C exams. In UPSC, they won't ask about these kind of facts. They will give statements which will correlate your understanding with the statements. Okay. After that, we move to the interior of the Earth. How the people are able to study Earth's interior. There are two major sources. Which are those sources? Good. Direct source and indirect source. In direct source, what all we cover? Good. Deep ocean drilling, volcanic eruption. Indirect sources?
Meteors, gravitation, magnetic force. Then
Seismic activities, which is a major important indirect sources for our study, seismic activity. Okay. Then how is Earth's interior divided? What is the first and foremost layer on the Earth? How much thickness does the crust have? 70. Approximately it is 30 kilometers. Whereas in areas where hills are present, it is up to 70-80 kilometers. What is the difference between oceanic crust and? I am asking about the difference between oceanic crust and the continental crust.
continental crust is more thick.
Oceanic crust is more thin. Which is more dense among? Oceanic crust is more denser compared to continental crust. After that, we have mantle. What is the thickness? Mantle thickness. You said. Sorry, your name? Vishwanath. Thickness of mantle. You said before this, you said. Yeah. Up to 2,900 kilometers. What is the important feature of mantle? Yeah. Upper part of the mantle is known as asthenosphere, which is famous for its molten magma. Molten magma, which will erupt during the volcanic eruption. After that, we have one more layer known as core. Core, we have two types of core. Outer core is called as outer core, which will be in which state? Liquid state. Inner core will be solid state. Why is outer core liquid whereas inner core solid? How can they say that? Even inner core also, the temperature will be very high, up to 5,000 to 6,000 kelvins. The temperature here in the core is up to 5,000 to 6,000 Kelvin, which is very high. Any rock will get molten only. But why the solid state at the inner core? Why not in the liquid core, in the outer core? No, that is not the reason. Just think, how can a deeper layer be solid and the outer layer be liquid? What may be the reason? Can I say? The deeper core remains solid because of enormous amount of pressure exerted on all the sides. Enormous amount of pressure. It is not because of the temperature. It is not because of the temperature, though the temperature is very high in the inner core also, because of pressure exerted from all the sides of the earth, the inner core remains solidified. It will be in solid state. What is the composition of upper crust? Good. In the mantle? Good. In the core, we have nickel and iron. It is known as Nephi layer. The mantle is known as Sima layer and the crust is known as Sia layer. Okay. After that, we have some discontinuities which I have not touched now. You just do one thing while coming tomorrow, just mention the discontinuities. Okay. First one is corner discontinuity. Second one is Moho's discontinuity. Just make it as homework. That's it. Okay. In advanced classes, we will go in detail about these discontinuities. As of now, just you make a list of discontinuities while coming tomorrow. Any doubts regarding yesterday's class? We are moving a bit technical today. Today's topic is geomorphology. First, understand what is geomorphology. What does that signify? What all we going to deal in this chapter? Okay, geomorphology. Geo in a sense, earth. What is morphology? Logy is equal to study. Logy in the sense study. What is morpho means? Morpho. Any guess? Morpho. Forms. In geomorphology, we are going to deal different various forms on the earth. Various forms. For example, mountain is a form. Mountain is a landform. In simple sense, in geomorphology, we are going to deal with various landform features. In broad terms, in geomorphology, we will cover various landform features which are seen on the surface of the earth. We doesn't go into the deeper layers or above the earth. We does not go on above earth like in atmosphere or in the hydrosphere. We just discuss the landforms which are present on the earth's surface. What are the kinds of various landforms you are seeing? Any few. After that, we can discuss how landforms are formed. Mountains, plains, plateaus, water bodies. One, I agree, mountain. Second, you told? Plains. Good. Then, plateaus. Anything else? Water bodies. Okay, let me take this side. Forest is not a landform. Majorly, these three are the major type of landforms found on Earth. These three are the major significant landforms found on Earth. Other than that, we have landforms formed due to various agents. Agents like air, water, have you heard of glaciers? Glaciers. These are the geomorphic agents. These agents also form various landforms. For example, running water. When the water is running, it will form river streams, right? River streams. River stream, while moving across its journey. For example, which is the river famous in Gulbarga? Which is the nearest river you have here? Which river flows? No rivers? Any one stream at least? No. No river streams. No river streams. No tributaries of Krishna flow in Gulbarga. No. No idea. Okay. In Bidar, Godavari's tributaries will flow in Bidar. Bhima, Krishna will not enter Gulbarga, I think. Bidar. In Bidar. Okay, I'm not sure about Bidar. In your district, actually in your district, the tributaries of Krishna will flow. Okay. For example, while the flow of Krishna, it will carry some sediments along with it. Is that right? It will carry some sediments along with its flow and it will deposit somewhere while draining into ocean. What will it do? Any river stream, it will carry some sediments in the upper course and it will deposit the same thing when it joins the ocean or sea. Is that right? While carrying, it will form some landforms which are called as erosional landforms. Erosional landforms are the something while the river it flows. While it is flowing, it will carry some sediments and form some landforms known as erosional landforms. When it is draining into ocean or sea, it will deposit something forming depositional landforms. Is this clear? There are two kinds of landforms in this. One is erosional type of landform and the other one is depositional type of landforms. It is same with groundwater, glaciers, wind, etc. Okay, it is same to same, similar to running water. We have two kinds of landforms forming. One is erosional landform and another one is depositional landform. Okay, this is just an overview. After this, let us understand how these landforms are formed. Just continuation of yesterday's class. Yesterday we have dealt with plate tectonic theory, right? In plate tectonic theory, we have three major kinds of plates, plate boundaries. Now let us try to understand these plate boundaries. After that, we can directly go into the chapter. Okay. First thing is there are three major kinds of plate boundaries. Okay. First form of boundary is divergent plate boundary. Any new lands. Later this, you can take the notes along with slides. Just I'm trying make you to understand now. Okay, just try to understand while I'm teaching. First type of boundary is divergent plate boundaries. Here what happens? The two plates, be it continental plate or oceanic plate or one oceanic and one continental plate. It will move apart. Continental plate or oceanic plate, or ocean and a continental plate move apart. Just think when two plates are moving apart, what will happen in the center? It is known as diversion. When they are moving apart, it is known as diversion. What will happen at the center? They will form a gap. Does the earth, in the earth's crust, when the gap is formed, it will remain as it is or it will get filled? It will be filled with what? Water? No, not water. Mountains. What does asthenosphere contain? When the crust crack, it will open it into asthenosphere. What does asthenosphere has? Yeah, molten magma. The molten magma gets erupted from this divergent boundary. This molten magma forms a new landform over the earth. This new landforms are nothing but it can be a mountain or it can be a small domes. It can be a mountain or small domes. Anything it may be, it will form a new lands. After that, we have convergent boundaries. Convergent boundaries are one, two continental crust or two oceanic crust or one continental and one oceanic crust meet each other. When they will meet, what happens? When two, for example, two vehicles meet, what will happen? Yeah, it will collapse. Hence, the convergent boundary is known as destructive boundary. It is known as destructive boundary. Okay, when two things, for example, imagine this is continental crust, this is oceanic crust. When continental crust and oceanic crust meet each other or converge at each other, which is more denser? Which is more denser, continental crust or oceanic crust? Oceanic crust is more denser, then which will go one below the other? Which will go below and which will stay above? No. Oceanic crust will subduct. It will go below the continental crust. Why this happens? Because of higher density. Oceanic crust has more density of 2.9 gram per centimeter cube, whereas continental crust 2.7. It will remain upper and this will go down. What happens when such convergence occur, you know? They will form something like this. Continental crust. This is oceanic crust. It will subduct, joining along with magma in the asthenosphere, and it will melt. Oceanic crust will melt. Whereas in continental crust, due to some exertion of pressure by the oceanic crust, it will form some landform features like volcanic mountains or simply a fold mountain will be formed. What will be formed at the convergence? Boundary of convergence, we have mountains and formation of oceanic crust forms magma. This magma, sometimes there will be also formation of, at this border, there will be formation of trenches. Trenches are nothing but deep ones. Trenches are also formed at such boundaries, convergent boundaries. In divergent boundaries, we have new landforms, whereas in convergent boundaries, these are destructive plate boundaries. Okay. After that, we have transform boundary. What does transform boundary signifies? What does the thing happen in transform boundary or that they just yeah, exactly right. They just slide, they just transform, they just touch each other. They just move, sliding each other. No such major landforms are formed. There is only small minor changes in the landforms existing. Pre-existing landforms ಅಲ್ಲಿ ಸ್ವಲ್ಪ changes ಆಗುತ್ತೆ. There may be some points where we can see earthquake. Earthquakes can be seen at some junctions of transform boundary. Even in the convergent boundary, even in divergent boundary, in any boundary, we see earthquakes. Anything which, when the plate moves, we see tremendous amount of energy releasing, which is nothing but earthquakes. Earthquakes are formed at all the three boundaries, be it convergent boundary, be it divergent or transform boundary. Have you understood this? There are three kinds of boundaries. These boundaries are responsible for formation of major landforms of the earth. Okay. We'll now take down what is geomorphology. Geomorphology is a systematic and organized description. Systematic and organized description and analysis of surface landforms, processes, and landscape evaluation of the evolution of the earth. Have you understand the concept? What is geomorphology? This is just keeping words. Just to memorize the words, it is systematic and organized description and analysis of surface landforms, processes, and landscape evolution of the earth. Landscape evolution of the earth. How to understand geomorphology is by understanding plate tectonics. Plate tectonics, according to plate tectonics, we have assumed that lithosphere is broken into series of separate plates. Below that plates we have upper mantle, which is known as asthenosphere. Then write down different types of plate boundaries. Give the heading plate tectonics. Under that you write down different types of plate movements. Types of plates movements. In that, first one is divergent plate boundaries. First one is divergent plate boundaries. Below that you write, it is known as constructive plate margin. It is known as constructive plate margin. Just draw this diagram. I will make it simple for you. Just draw two plates. Name it as, which is your favorite plate, continental plate or oceanic plate? Or name it as continental crust. Show the arrow, they are diverging from one another. They will be moving apart from one another. Yes. Yes. In the middle, you just make something like a ridge. To mention magma. Here you just make it ridge. Name it as ridge or mountain. Okay. Just take down a famous example of this ridge. A famous example of this divergent plate boundary is Mid-Atlantic Ridge. Where is Mid-Atlantic Ridge? In the middle of the Atlantic Ocean, we have this Mid-Atlantic Ridge where we see the two plate margins diverging one another, forming of a great ridge. Ridge is nothing but a chain of mountains is called as ridge. Clear? Second major type, constructive plate bound or convergent plate bound. Second one is convergent plate bound. It is also known as destructive plate margin. It is known as destructive plate margin. Draw one crust which is slightly smaller than the other. See, this is which one is thinner? Which one is thinner? Continent or oceanic? Oceanic crust is thinnest. Draw something which is thinner and name it as oceanic crust. And the thicker one is continental crust. Show the zone of subduction. Near the continent, show a ridge. Towards the continent, you show a ridge, whereas near to the oceanic crust, show something like this, which is called as zone of subduction. Zone of subduction. Okay. Near to the oceanic crust, just mark inverse triangle and name it as trench. It is famous for trenches. Can you name any trench? Any trench you know? Name of any trench? Mariana Trench. It is the deepest trench of a specific ocean, or deepest trench of our world is Mariana Trench. Such trenches happen near which type of plate boundaries? Convergent plate boundaries. Another example of convergent plate boundary. Take an example of convergent plate boundary. Our Himalayas. Himalayas formed due to convergence of Eurasian plate into Australian plate. Eurasian plate and Indo-Australian plate. Third important one is transform plate boundary, or it is known as passive plate boundary. Take down transform plate boundary. or passive plate boundary. Another name is conservative plate margin or boundary. Conservative plate in this type of plate boundaries, the two crust or two plates just simply slip over each other, slide or slip over each other. Just mention this one. The plates simply slip over each other. Next, the crust is neither created. The crust is neither created nor destroyed. Crust is not created nor destroyed. We can see, next point, we can see earthquakes, faults along such zones. We can see fault lines and earthquake along such zone of transform boundaries. Clear? Then we have geomorphology. Geomorphology, in this geomorphology, till now we discussed something known as endogenic forces. Now take a few moments just to understand the concept. Later that you can take the notes. Geomorphology, in this geomorphology we have forces. We need to study few forces which are very important for what? To understand the formation of landforms. In that forces, we divided them into two categories. One is endogenic forces. Other one is exogenic forces. Endo. What does the name endo says? What do you mean by endo? Something which is inside the earth. What is exo? Outside the earth. In this endogenic forces, we have two kinds. One is catastrophic forces. Another one is diastrophic forces. We will deal in detail about each one of this. Just understand, in endogenic forces are the forces which are present inside the earth. Among that, we have two kinds. One is catastrophic, another one is diastrophic. Catastrophic means what? One is sudden appearing. Some forces which are suddenly appears. For example, our earthquake. Does earthquake happens all of a sudden? Or will it give some hint before it coming? It happens all of a sudden. Earthquake happens all of a sudden. Such sudden occurring forces are one kind of forces. Another one is, example is orography. Orography in the sense, something which builds slowly. Something which builds slowly, slowly, day by day, it will build up and form a large mountain. Anything oro means a mountain. Orography means studying of mountains. Something which builds slowly. Our Himalayas, even still today, they are growing. They are growing a centimeter by centimeter, year on year. Such things are very slow process that is known as orographic forces. On the basis of occurrence, the speed of occurrence, we have divided them into endogenic forces into two categories. One is catastrophic, another one is diastrophic. One is fast occurring, another one is slowly occurring. Next one is exogenic forces, something above the earth surface. It will happen something above the earth surface. For example of exogenic forces, have you heard of weathering? Weathering. What is weathering? Hmm? Weather is different. Weathering is different. What is, yeah, forming of soil. A breaking down of large particle into smaller particles is known as weathering. This is the second, which happens above the earth surface, above the ground surface, it will happen. Whereas endogenic forces happens at asthenosphere level. Okay, these are happening below the earth surface, in below the crust. Among exogenic forces, we have weathering. Weathering, what is weathering in a sense? A large particle, for example, rock, is broken down into smaller ones, like soil. Formation of soil is best example of weathering. In weathering, we have various kinds like physical weathering, chemical weathering, and biological weathering, which we will deal later on. After that, exogenic forces are in the chemical, whereas exogenic forces, we have other agents of causing air loss, as we discussed earlier. Which are the agents? Agents which cause
Wind.
good wind. Then running water, groundwater, glacier, then oceanic currents, tides related to oceanic waves. These are all agents which causes various different features of landforms. Okay, this is the major thematic flow or flow chart of studying geomorphological processes. Take down this. Up to here you just write. In that book only you just write, so that it will be easy for your revision. Geomorphic processes. That we have two types. One is endogenic, the other one is exogenic. In endogenic, majorly two types. One is diastrophism. Mention this word, diastrophism, which means slow movement. Second one, catastrophism, which means sudden movement. In diastrophism, there are two types of diastrophism. One is vertical growth, vertical continent building, vertical continent building. The other one is horizontal continent growth or continent building. Next, catastrophism. In that two types. sudden occurrence, volcanism and earthquake. Volcanism and earthquake. Next, right, exogenic. Exogenic. In that, weathering, we have three kinds: physical, chemical, biological. Then you have erosion and depositional landforms of these two are same for both, just right in the middle of these two. Running water, groundwater, glaciers, wave currents, and winds. Winds, last. Okay. Completed. In this class, we are dealing with diastrophism only. Okay, we are not dealing with sudden movement or catastrophic movements are not dealt in this class. Catastrophic movements, actually earthquake need an extra class of 3 hours. Okay, that we are not going to cover in this foundation course. Earthquake, volcanism, these are dealt in your advanced courses. There are various kinds of volcanoes and their differences. You will read that later on. In these classes, we just touch into diastrophism. In diastrophism, which is a slow movement, our focus is to learn about mountains. How are mountains developed? What are the process behind development of mountains? And two major kinds of mountain. One is fold mountain. Another one is block mountain. Study of mountain is known as orography, whereas the process in which orogenesis is the process from which mountains are developed. In this class, let us try to understand how mountains are developed. Orogenesis. What is orogenesis? The process of mountain building. In simple words, the process of mountain building is known as orogenesis. How is mountains developed? That is what we study. First one, just understand, later then you can make the notes of this. Any major landform is formed due to, according to which theory? Plate tectonic theory. Our mountains formed, in simple terms, mountains are formed wherever we see convergence. Convergence is the background for the mountain formation. Convergence, be it continental-continent convergence, oceanic-continental convergence, or oceanic crust convergence. Wherever we find convergent plate boundaries, we see formation of mountains or orogenesis. There are two kinds of mountain. First one is fold mountain. The second major type is block mountain. First one is fold mountain and second one is block mountain. Just understand how these fold mountains are formed. Do you have an extra book? Any book? Yeah. Just in simple terms, fold mountains are nothing but, just imagine, where is the center? Okay. This is one plate boundary and this is another plate boundary. These two plates are converging. These two are coming closer to one another, and I will hold like this. These two plate boundaries, one plate boundary, this is continental plate and this is another plate, continental plate. When they come close to one another, there will be some tension created, right? When they will come close, there will be some tension created. That tension will increase the height. How they will look? It looks like folded. Something is folded. That is why the name fold mountain. What happened to this? Well, how is fold mountains formed? When two continental crusts or two oceanic crusts come close together, they will build some tension between the plates, and that tension will give rise to something that is rising, that is known as fold mountain. It is as simple because of the tension at the plate boundaries. Tension at the plate boundary. Whereas block mountains, later on I will give the notes. Next we have block mountains. How are block mountains formed? Just imagine these are two plates. In formation of black mountain, we have a fault region. We have something called faults. Faults are nothing but the line or the area where the stress, pressure, stress is nothing but pressure. In simple terms, pressure is exerted at some line. That line, along that line we have called, these lines are called as fault lines. For example, you are cutting a watermelon. In watermelon, think this is a piece of watermelon. You just keep the knife here at one region and another knife here. When you press this knife and this knife at a time, when you press both the knives at a time, what will happen to the middle piece? The middle piece will, what will happen? Just take a piece of watermelon. This is one watermelon. Just keep a knife here and knife here. If you press both gently at same time, if you press this knife also, what will happen to the middle piece? It will cut. It will cut and either it will move down or it will move upward. Is that right? Because of the pressure exerted from both the sides, the middle piece will get cut and it will move either downwards or either upwards. If that piece, if it moves downwards, it will form a garden. For example, think that our watermelon has moved a little bit downward. That piece has moved little bit downward, forming a garden, which is also called as Rift Valley. What will that piece form is known as Rift Valley. The low-lying area is called as Rift Valley. In case, if our watermelon, if the cut piece of a watermelon will rise up, imagine it will rise up, it will displace upwards. Then it will form something called as block mountain. If something rises, If it goes down, it will form Rift Valley. If it will rise, it will form Block Mountain. That piece will form Block Mountain. It will stand upon the other two pieces. It will form Block Mountain. Understand how fold mountains are formed? Because of two stresses acting one another, it will rise something in the middle, forming a fold-like structure called as fold mountain, whereas block mountains are formed when two stresses acts parallel to each other and they cut down the middle portion. In formation of block mountains, we will always see Rift Valley associated with it. These block mountains will form in a series. In a series. Here also it will act the fault line. There will be a fault line. Here will be fault line. In such series happening of block mountain formation, we will found something like this. Where we see the uplifted one is called as block mountain and the low lying one is called as Rift Valley. Is the concept clear? Our block mountains and fold mountains form. Later on, we will discuss about the examples of few mountains of the world. You need to know few major mountains of the world because there will be match the following kind of questions where they will give few famous mountains and the countries to which they belong or the continents to which they belong. Okay. Take down. First one, diastrophic forces. Diastrophic forces. These are slow developing processes. In that subheading, orogenesis or orogenetic movements. Orogenetic movements. Simple definition. It involves orogenetic movements. It involves mountain development, mountain building, due to compressional force or shear stress. Shear stress. SHEER. Shear stress. This is all you don't want as of now. Okay. Under that, you take the two kinds of mountains, two types of mountains. One is fold mountain. Other one is block mountains. Fold mountains, below that, due to compression, in block mountains, due to shear stress, due to shear stress. I'm making it simple, not to take the whole thing. Okay. Have you understand the concept? Shear stress and compress. You just go through your NCERTs, that will be enough. I will understand where all, which boundaries we will see mountain formation in which boundaries? Orogenesis, where In which plate boundaries we will see mountain formation? Sorry? Tectonic plates. Good. Tectonic plates. Which kind of plates? Convergent, divergent, or transform boundaries? Good. In convergent plate boundaries, we will see mountain formation. Take down these three. Mountains are formed at the plate boundaries. At the plate boundaries or plate margins. First one, collision of two oceanic plates, like collision of two oceanic plates. Second one, at collision of two continental plates. Collision of two continental plates. Third major boundary, collision of a oceanic and a continental plate. Collision of a oceanic and a continental plate. Collision is nothing but convergence. For each one, you will get more examples, more number of examples. You can learn this in your advanced courses. As of now, just understand the basic overview. Where we have found the mountains is nothing but at the plate margins of convergence. Convergence of collision plate boundaries. Then this is the main thing which you have to read for your Group C exams. For example, PC, PSI or BT, FDA, SD exams. In such exams, they will give a match the following along with the continent and the mountain. First, just learn, try to learn. This is which continent? North American continent. Just try to learn 3 to 4 important mountain ranges in each continent. In North America, we have famous mountain range known as Rockies. Rockies is the longest among North American mountain ranges. It comes, you should know the direction of alignment also. It comes in the northwestern direction, that is Rockies. After Rockies, we have Appalachian mountain range. Appalachian is a North American mountain range towards the Atlantic Ocean. Appalachian. Okay. Then we have Sierra Nevada and Sierra Madre. Sierra Madre. S-I-E-R-R-A. Sierra Nevada and Sierra Madre. Okay. These are the 4 important mountain ranges in which continent? North America. In South America, we have many minor mountains, but important one is Andes. Andes is the longest mountain range in the South American continent. Which is the longest mountain range? Andes. After that, we have Africa. In Africa, just know 2-3 ones. Famous one is Atlas Mountains. Atlas Mountain is in Africa. It borders the Mediterranean Sea and it is famous because of it access climate and natural divide. Atlas. Where is Atlas? It is in northwestern Africa. You should know the direction of alignment also. It is in the Africa. After that, one more, Draxenberg. What is this one known as? In the southern direction, southeastern Africa, we have Draxenberg. Learn major ones, Draxenberg and Atlas. After that, we have Europe. In Europe, you should know at least 3. One is Alps. Where is Alps located? Alps is located in the Europe, which is nearer to the Mediterranean part. Towards Mediterranean, we have famous mountain known as Alps. After Alps, we should know Scandinavian mountains. Scandinavian mountains are famous because they will avoid the extreme cold winds coming from the Arctic region. We have polar regions here. Polar regions in the sense, these are ice regions. From there, we have extreme cold winds coming towards the Europe, which is avoided by the Scandinavian mountains. Scandinavian mountains comes in Norway, Sweden, Finland. After that, we have Caucasus range. Before moving to that, Ural mountain is a natural divide between Europe and Asia. We have Ural mountains which acts as a natural divide between Europe and Asia. After that, we have Asia. In Asia, famous mountain range in India. Which is the famous mountain range in India? Himalayas. Good. Himalayan mountain range. In Asia, we have famous mountain range, Himalayas. After Himalayas, India has another range of mountains which are not as tall as Mount Himalayas. These are known as Ghats. Have you heard of Western Ghats and Eastern Ghats? These two are also mountain ranges of India. After this, we have Zagros. In Iran region, in West Asian region, we have famous mountain called as Zagros. Above that, we have Caucasus. Above that range, we have Caucasus. After that, we have in the China region, we have Tian Shan. In Mongolia region, we have Altai mountains. In Africa, we have read about Atlas mountain, whereas in Asia, we have Altai mountains. These are some of the famous mountains of our Asia. After last, we have our Oceania or Australia. There we have one famous range which is known as Great Dividing Range. Great Dividing Range is a famous mountain range in Australia or Oceania. These are few mountain ranges of the world. You should make a list of this. Just write North American continent. In North America, you will mention 3. In South America, 3 to 4. Like that, you will just memorize some of the important mountain ranges. Let us take a break for 10 minutes. We can start. Is the concept clear for you? Any doubts? Is the space okay? Is come speed a bit? It's okay. You need videos. Okay. Go on the same PDF. The slides will be on. Yes. Is that okay?
Not discussed today. What is it from first to last class?
Okay. After every class, you need the videos to share. Okay. After that, you take this video.
ಇವತ್ತು ವಾಲ್ಮೀಕಿ ಜಯಂತಿ ಅಸಲಿಗೆ ಹಾಲಿಡೇ ಇದು ಮುಗಿತಾ ದಸರಾ ರಜೆ ಮುಗಿತಾ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು
ಇದು ನೋಟ್ಸ್ ಮಾಡ್ತೀರಾ ನೀವು ಈಚ್ ಕಾಂಟಿನೆಂಟ್ ವೈಸ್ just name them. If you are not interested to take this diagram, just name North America. In North America, just list 1, 2, 3. And similarly, in South America, in Europe and Africa, Asia, and in Oceania or Australia. Then we have classification of mountains. Already we know there are two major classification. One is fold mountain and other one is block mountain. Apart from fold and block mountain, we have still two more types, that is volcanic mountains and residual mountains. In fold mountain, you already mentioned fold mountain is formed due to which form of stress? Which form of stress? Is it compressional or shear stress? Fold mountains are majorly formed due to compression. Due to compression, in fold mountains, we have something crust and troughs. We have two things. One is crust and the another one is trough. How these crust and troughs are formed? Because of compression. Due to compression, we have synclines known as troughs and anticlines known as crust, which are part of fold mountains. Just mention like this. These are known as troughs and the low-lying parts are known as crust. In fold mountains, we majorly have two major features. One is troughs, another one is crust. It is easy to write, no? Just like this. Crust and troughs. Example for fold mountain. The famous example which is present in India. Yeah, Himalayas are the best example of fold mountains. Take down example for fold mountain, our Himalayas. Then Rockies in North America. Where is Rockies? North American, which part of North America? Whether in north, south, east, west? Good. It is northwestern part of North America, which is Rockies. Take 1, 2, 3 examples of fold mountains. In exam, they will give a question. Which of the following is not a fold mountain? For that, you should know few examples of fold mountains. First one is our Himalayas. Second one is Rocky Mountains of North America. Andes in South America. Alps in Europe. Andes, Alps. Just 4 examples. Himalayas, Rockies, Andes, and Alps. Next measure we have fold mountains. Fold mountains due to which type of stress? No. Fold mountains, sorry, block mountains? Shear stress. The force of tension originating inside the earth, these have parallel forces. Parallel forces acting. Formation of two things. One is, what is this low-lying area? This is Rift Valley and the upward area, block mountains. In fold mountain, just take down a simple diagram. In block mountain, just take this diagram. We have upraised platforms known as horse and low-lying things are known as gravel. These horse are nothing but our block mountains. In Graben, these are nothing but our rift valleys. Is this clear? Examples, few examples for rift valleys or the famous block mountains. This is the famous example, Black Forest Mountains in Germany. Black Forest Mountain is a very good example of block mountain, called block mountain. Black Forest Mountain. After that, we have Sierra Nevada. Where is the Sierra Nevada located? In the map also, we read about this Sierra Nevada. Where have you seen that?
Not
Good. In North America, Sierra Nevada. In Africa, we have Great African Rift Valley. Africa, we have Great African Rift Valley. Third major type of mountain is volcanic mountain. Volcanic mountains are formed wherever we see volcanic eruption. Just listen this. This is a outer portion of the earth which is called as crust. Below this crust, what we have? Mantle. In mantle, what is the content? Silicon and magnesium. How it is in the form? Which form? Molten magma. In some places of the earth, this molten magma starts to erupt. It will starts to erupt and it will build some features like this called as volcanic mountains. During the formation of volcanic mountains, we can see various landform features forming. One is when volcano erupts, if the volcano has the magma which is dense. If the magma is dense, it will build something like mountain. If the magma is dense, it will build mountains. If magma is less dense, if magma is less dense, these volcanoes will not construct into mountains. They will spread evenly. They will spread and forms something like plateau regions. If magma is less dense, they will form what? Plateaus. If magma is more dense means more thick magma, it will form creations, long creations, vertical developments. These developments are called as volcanic mountains. Can you give any example of volcanic mountains? Have you heard of any volcanoes or have you read of any volcanoes in your newspapers? Any name of volcanoes? Any name? In India, we have a famous volcano, Norkondam. Have you heard of this? Norkondam. No? Barren. These are the two volcanic eruptions in India. Where does this stands? These are in Andaman and Nicobar region. Where there's Narkondam and Barren are seen in Andaman and Nicobar. These are not famous for the world, but for Indian perspective, these two are the volcanic eruptions seen in India. One is Narkondam and the other one is Barren Islands. In world, we have Mount Etna, which is famous. Hawaiian mountains. Take one or two examples for volcanic mountains. One, Mount Etna. ETNA, Mount Etna. Have you heard of Hawaii? At least in news, you heard of this word Hawaii. Hawaiian mountains are also of volcanic eruption. Then fourth major kind of mountain is your residual mountains, or also called as relict mountain. Just understand this. What are residual mountains? First, we have tall mountains, mountains are something which is above 1500 meters high. Okay. These tall mountains, due to exogenic forces, like what are exogenic forces? Good. Exogenic forces act upon these tall mountains and they will erode the top layer. This top layer get eroded, and the height of the mountain will decrease. This much is decreased due to activities of exogenic forces. This remaining mountain, what we call it as residual mountain. In simple terms, residual mountains are nothing but these are byproducts after weathering or acting upon by exogenic forces. You should know few examples of residual mountains in India. The famous one is Aravali. Have you heard of this Aravali mountains? Aravali, Mount Abu. Yeah, this mountain Aravali is present in which area? Any idea? Good. In this Rajasthan region, we have Aravali mountains. Aravali is the famous example of residual type of mountain. Just mention this. Residual mountain is the fourth important type of mountain. You know why the mountain reside? Because of presence of weathering or acting upon of exogenic forces. Okay. In that, take on two examples. One is Aravali. The second one is Raj Mahal Hills. Where is this Raj Mahal Hills located? Here, in the eastern parts, we have Raj Mahal Hills. Okay. Raj Mahal Hills. Third one is Nilgiris. Where is Nilgiris located? In the Western Ghats, this region. These are few examples of relief mountains. The mountains which are present after erosion by exogenic agents. Then we have major landforms called as plateaus. Let us understand what are plateaus and how are they formed. Is everything cleared about mountains? Mountain is the first major landform feature. After that, we have plateaus. How are these plateau regions formed? Plateaus, what are plateaus? First, we should know what are plateaus. Mountain is something which is elevated above 1500 meters, whereas plateaus are something which has flat tops, and steep elevation. How does plateaus looks in the sense? They have flat top. But there are some elevation at the steeps. This is known as steep slopes. This kind of structures are called plateau regions. Have you seen any plateau? Any famous plateau? Have heard of any plateau's name? Name of any plateau? India, we have one famous plateau. In the South India. We are all part of that. Have you heard of that? Deccan Plateau. What are plateaus in the sense? Plateaus are simply flat top tablelands with steep elevations along the sides. Then, if you want to recall something related to plateau, just remember Deccan Plateaus. Okay. Why the plateaus are important? Why it is significant to study? What is the significance of plateaus? Why plateaus are important? Just because they are very much rich in yeah, they are very much rich in minerals, mineral resources. For example, in Deccan Plateau, we will find many mines in Deccan Plateau. For example, we have many iron mines, coal mines, then we have even gold mines, we have diamond mines in Deccan. Whereas in North India, we does not found such mineral resources in North India because they are devoid of these plateau areas. Whereas the South India is famous for its plateau regions. In Karnataka also we have separate tablelands. For example, Mysore Plateau, Bangalore Plateau, Raichur Plateau. In such, these are some smaller parts of major Deccan Plateau. Deccan Plateau is a large plateau of South India. Knowing its significance, let us understand how these plateaus are formed. How are mountains formed? How are mountains formed? Orogenesis. At plate margins, we have some stress working which will lead to mountain building. Now we understand plateau formation. There are two major kinds of plateaus in the world. One is known as dissected plateau and the other one is known as volcanic plateau. Understand this just. Dissected plateau. What are dissected plateaus in the sense? When two plates, be it continental plate or oceanic plates, when they collide or when they move apart, when there is some movement at the plate boundaries, one plate will rise, the other plate will subduct. In such areas, we have dissected plateau. When in the movement of plates, we have dissected plateaus, where one side of the plateau will be upraised, that is called plateau area, and the other one low lying is called as graben. Same to that. Next, we have volcanic plateaus. How are volcanic plateaus formed? In the sense, when volcanoes erupt, when volcanic eruption is occurring, when volcanoes erupt, the liquid magma, when magma is less dense, when magma is less dense, density of magma, if the density of magma is less, it will spread out evenly. It will does not form a tall creatures or tall structures like mountain. It will spread out uniformly, forming a flat table land like structure called as plateau. When magma is less dense, it will give rise to volcanic plateau. Best example of our volcanic plateau is this Deccan Plateau, because Deccan is formed way back in Mesozoic era, where the how is Deccan formed? Just know about this. In this Maharashtra, here we have Maharashtrian region, right? Maharashtra, Gujarat region, we have a volcanic flow. Volcanic magma flow, that magma is very much less in density, which is majorly a basaltic magma. Which kind of magma? In volcanic chapter, you will learn about what are basaltic magma, what are granitic magma. Just for this understanding, you should know it is less dense magma, which is basaltic magma is less dense magma. It's flowed in the geological time scale, forming a new feature called Deccan Trap, giving rise to Deccan Plateau. Have you understand how these plateaus are formed? One is due to dissected plateau formed due to plate movement. In simple terms, plate movements gives rise to dissected plateau. In volcanic plateaus, how are these volcanic plateaus formed? When When magma is less dense, it's spread out evenly, forming a flat tableland. Flat tableland giving rise to a plateau, volcanic plateau. Have understood about this? Okay. Major plateau in India, you should know about Deccan Plateau. Just Google something about Deccan. While coming tomorrow, just you should know name states in which Deccan is spread. Deccan Plateau is spread. Okay. States. Deccan Plateau covers how many states and name them. Okay. Take down plateaus. It is an elevated area. Plateau is an elevated area. It is an elevated area with nearly even surface. With nearly even surface on its top. Even surface on its tops and steep slopes along the sides. Steep slopes along its sides. Steep slopes along its sides. These are also called as, next sentence, these are also called as tablelands. These are also called as tablelands. Classification. Plateaus classified into two types. One is dissected plateau. The other one is volcanic plateau. First one, dissected plateau formed as a result of upward movement of crust. Formed as a result of upward movement of crust caused by slow collision of tectonic plates. Slow collision of tectonic plates. Example for this, take down one example. Colorado Plateau. It is in North America. Colorado Plateau. It is a famous plateau, rich in mineral resources. Colorado Plateau. Second type is volcanic plateau. Formed due to eruption of small volcanoes which have less dense magma. Example for this is Deccan Plateau. Deccan Plateau. Okay. Then we have plains. Third important landform feature is plain. How can we define plain? As the name suggests, plains, what does it signifies? These are flat with less elevation differences. How can we define plain? A simple definition. These are flat lands with less or low elevation differences. There are no differences. The gradient is same. The gradient remain same. They remain same. Less elevational differences can be seen. Then after understanding mountain formation and plateau formation, you can tell me now how plains are formed. What may be the reasons in formation of plains? What may be the cause? How plains are formed? Good. The major reason for the formation of plains are erosion. This erosion can be done by the wind or by water. Simply, this erosion can be done in two ways, one by wind and other by water. These erosional agents, wind and water, they will erode the topmost layer, forming a flat lands. These flat lands can be a smaller area or can be a larger areas. Best example of planar regions are riverine beds. For example, Gangetic belt, entire Ganga region, entire northern region where Ganga flows, we see plains. That is known as largest plain. Ganga plains in India and Brahmaputra plains in India are the largest plains of India. In the world, which is the largest plain? Which is the largest river in the world? Which is the largest river in the world? Amazon? Have you heard of it? Amazon. In that stretches, we will find largest planar regions. Okay. How are plains formed? Due to erosion and deposition by some erosion agents like wind and water. We define plains as the areas with minimal elevational differences or less or low elevational differences. These are plain regions. How they look is just as simple as that your agricultural lands, your farmlands, when they are leveled. Before sowing, the farmers will level up their land. Some lands have undulations, some have hill-like areas, some have depressions like ponds. The farmers will level up by cutting off this top layer and filling this ground. Level up before cultivating. The planar regions are naturally level because of erosion agents like water and wind. These planar regions, when we look, they have gradient differences equal to or nearly equal to 0. Gradient is nothing but slope. Gradient is nothing but slope. The gradient difference in the planar region is nearer to the 0. Then types of plains. It is very simple. One is depositional plains, one is erosional plains. The other is structural plains and lava plains. There is nothing much to think about here. When we say erosional plains, these are plains formed due to the erosion of water or erosion of some land formed due to water or wind action. Whereas depositional plains, how are depositional plains formed? Due to deposition of sediments. When the river flows, they will deposit something at their mouth. At the depositional areas, we will find depositional plains. And structural plains. What do you understand by the word structural plains? Think this is a hill, small hill like thing. It will undergo landslide. Landslide is nothing but wearing and tearing of some part of the hill. When it undergoes landslide, it will form something. This part is displaced and it will sit here. Right? This part of hill will get displaced and it will sit at the end of the small hill. There we found something known as structural plains. This is known as structural plains due to upliftment and movement of large land masses. Here, the cut part of this hill is displaced and formed a structural plain. Then we have lava plains. What are lava plains? Lava plains are nothing but these volcanic plains. The volcanoes, when volcanoes are erupted, think this is volcanic eruption happening. When volcanoes erupted, when the magma is less dense means how they appear, where they are thick or thin. very, very thin like water. When they are very thin like water, they will run. They doesn't form long or large vertical structure. They will run and forms plates. When magma is very, very less dense, they will form a structures called as lava plains. These are kinds of plains. Just mention the names. Definition you can understand yourself by reading the names. Types of plains. One is depositional plains. Second one, erosional plains. Third one, structural plains. Fourth one, lava plains. Oh. After covering this, until now we have discussed about few of the endogenic forces which are helping to form landforms like mountains, plateaus and plains. Now we have minor landform features. Those three are major. Now we are dealing with minor landforms. Minor landforms are caused due to exogenic forces, the forces which are generated above the Earth's surface. In exogenic forces, first type we will study is the weathering. In simple terms, how can we define weathering in a sense? It is breaking down of larger particles into smaller simple ones. In weathering, we have breaking. In weathering, we will discuss three major kinds of weathering. Just understand, after that you can take the notes. First kind is physical weathering. Second one is chemical weathering. First, physical weathering. What is weathering? Just it is breaking of large particles into smaller particles in simple sentence. First, in physical weathering, what happens, you know, there is no change in the form. For example, if this is a large rock particle that will broken down into a smaller soil pieces or small particles without changing the form. What I am meaning to say is there is no chemical change. Just imagine something like a brick, a red brick. When the red brick is cut into small pieces, it is known as physical weathering. Then the same brick, the red brick, when you immerse the brick in water, when you immerse the brick in water, it will undergo some chemical reaction with the water. Exactly right. It will undergo some chemical reaction like hydration. It will absorb water, right? That is known as hydration. It will undergo oxidation. This is known as chemical weathering. It will change its form. That is known as chemical weathering. In physical weathering, what all we studied? Majorly, physical weathering happens due to few things like temperature change. When can we see physical weathering happen? Is when temperature change. Where we find extreme temperature changes. In which places we find extreme temperature changes? ಎಲ್ಲಿ ನೋಡಬಹುದು ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಆಗೋದು? ಬೆಳಿಗ್ಗೆ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಬಿಸಿಲಿರುತ್ತೆ, ಸಂಜೆ ಬಂದ ಕೂಡಲೇ ತುಂಬಾ ಕಮ್ಮಿ ಟೆಂಪರೇಚರ್ ಹೋಗ್ಬಿಡುತ್ತೆ, -ಡಿಗ್ರಿ ತನಕನೂ ಹೋಗುತ್ತೆ. ಯಾವ ತರ ಏರಿಯಾಸ್ ಅಲ್ಲಿ ನೋಡ್ತೀರಾ ಎಕ್ಸ್ಟ್ರೀಮ್ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್? ಡೆಸರ್ಟ್ ರೀಜನ್ಸ್. ಡೆಸರ್ಟ್ಸ್ ಅಲ್ಲಿ ಮಾರ್ನಿಂಗ್ ತುಂಬಾ ಚಂದ ಬಿಸಿಲಿರುತ್ತೆ, ನೈಟ್ ವಿ ಹ್ಯಾವ್ very low temperature. Example, desert regions. Even in Raichur, Gulbarga, illellanu kuda we can see physical weathering due to change in temperature, but extremely we see in desert regions. Okay, temperatures change. Second one is in glacier or snow falling regions. Have you heard of anomaly of water? Water has something known as anomaly. Anomaly is nothing but it is abnormal behavior of water. What is this anomaly of water? At few degrees Celsius, at 1 to 4 degrees Celsius, when the temperature is low, it will expand. Have you heard of this in your childhood days? The anomaly of water. When the temperature decreases, the water volume increases. Have you observed in the fridge also? Do you have ice tray experiment in this ice tray? ಐಸ್ ಟ್ರೇಲಿ ನೀವು ನೀರ್ ಹಾಕಿಟ್ಟಾಗ ಅದು ನೀರು ನೀವು ಒಂದ್ ಮುಕ್ಕಾಲ್ ತುಂಬಿಸಿದ್ರೆ ಆಮೇಲೆ when it become ice, it has expanded itself and the length of ice has been increased. Same, the anomaly of water helps to weather the rocks. For example, in the glacier region, we have rocks. In the cracks and crevices, we have snow deposits. Isn't that the snow will deposit in smaller particles of rocks? In smaller cracks and crevices of the rocks, the snow will deposit. Due to anomaly of water, this water will expand when the temperature changes, and this expansion and contraction of water vapors, waters or snow causes the cracks in the stones. In the which areas? In temperate regions. In temperate regions, the expansion and contraction of water in the cracks and crevices causes the weathering rocks. After that, where all we can see this physical weathering? When there is high wind, high intensity of wind blowing, these rocks will get wearing and tearing down. When the wind flows, they will erode the topmost layer of the rocks. Thus, it is also one of the agent of erosion. Physical weathering is nothing but disintegration. Just remember this word, disintegration. What we find in physical weathering is just disintegration of larger rock particles into smaller ones. Okay. Then we have chemical weathering. How is chemical weathering? In chemical weathering, we have change in form. How the form is changed? For example, you have ever heard of limestone? Limestone is famous example of chemical weathering. Limestone, ಸುಣ್ಣದ ಕಲ್ಲು ಕೇಳಿದಿರಾ? ಕಲ್ಲಲ್ಲಿ ಸುಣ್ಣದ ಕಲ್ಲು. When we are kids, we used to have this limestone and we write. If you are visiting some tourist places near the hills, they will write some names. For example, some names on these stones, right? They will write by using these limestones. Limestones are vulnerable to weathering, very much vulnerable. They undergo easy chemical weathering. When such vulnerable rocks like limestone undergoes hydration. Hydration is simple terms. When these rocks, when the rain comes, they will hold some amount of water in them. This phenomenon is known as hydration. They will absorb some amount of water and the phenomenon is known as hydration. Such hydration will weaken the rock particles and they will disintegrate the rock particles. Then we have oxidation, redox reactions. Redox reactions is nothing but oxidation and chemical changes. Other chemical changes happen. In this, what happens, you know? For example, you have an iron-rich mineral. For example, hematite, magnetite. Have you heard of these minerals? Tomorrow we will discuss about minerals. Iron-rich mineral, when it attracts towards oxygen, it will be called as oxidation. Many minerals undergoes oxidation and they will change its forms. That is, in simple terms, such oxidation redox reactions are helping for chemical weathering of rock particles. Then third major one is biological weathering. This happens due to microbes, plants, animals, dead and decayed matter. Dead and decayed material. How is biological weathering happening? For example, imagine a large rock. There are some plants growing. Example, mosses, lichens, or imagine a shrub. A shrub is growing in this rock. This shrub or plant, they will emit some types of chemicals at their roots. They will emit some types of chemicals, that is smaller acids, like example hydrochloric acid or H2SO4. They emit such chemicals in smaller amounts. These chemicals will help to degrade the rock particles. That emission will help to degrade the rock particles and helps to disintegrate into smaller particles. I will understand three major types of weathering. Okay, take down weathering. It is a general process by which rocks are broken down at the earth's surface into sediments, clay, soil, etc. Then just make a column like this: types of weathering. Name it: types of weathering, physical weathering, chemical weathering, and biological weathering. Under physical weathering, you don't have to take all this. Just mention what I will say. Frost weathering. Frost, as I explained, no? Frost weathering, if you have understood this, there is no need to take down the sentence. Frost weathering. Frost is nothing but floating and thawing of ice crystals. Frost weathering. Or frost. Second one, temperature differences. Temperature difference. Third one, wind. In chemical weathering, take down hydration. Hydration. Oxidation. Oxidation. Carbonation. Carbonation. Then biological weathering due to microbes. Mention microbes, plants, and animals. Now just listen. Among exogenic agents, we are dealing one by one now. First one is running water. First important one is running water. Before moving to the chapter, just imagine where does water come from? In the form of rain. In the form of rain, in the form of precipitation, water comes to earth from clouds. Isn't it right? Okay. When water splashes, when water hit the ground, imagine these are raindrops. When it hit the ground, what will it form? Small lakes, rivers. In depression areas, it will collect it and form lakes and rivers. In normal areas like in our roadside, what will this waterfall mix? When these raindrops fall on the ground where there is no lake, pond or ocean, seas, what will it form? It will splash. It will splash on the ground and it will form something like splash erosion. It is called as splash erosion. Have you observed something like when the raindrops are quite usual, are quite larger raindrops, when it falls on the ground with some pressure, it will turn the mud into a cup shape. It will turn the mud into a small cup shape like this. Have you observed this? This is known as splash erosion. This occurs when the rain starts, when just rain starts to fall. Okay. After this, then we have several splashes joining together to form a small rill. In roads, if you observe, you have tar road here. If you observe alongside the tar road, we have small streams running. Have you observed this? Along the sides of both tar roads, we have small streams running during rainy season. These are known as rills. Several rills, they will join, several rills will join and form something which is a deeper layer which is called as gully. Several rills joins to form something which is high in intensity known as gullies. Okay, this is clear. When simple rain occurs, we can see all this. One is splash erosion, second one is rill, and third one is gullies. Okay. Now, this is based on your experience. Now, let us understand the running water. It is not only now the precipitation or the rainfall, it is now the river system. River system. River system is the best example of running water, isn't it? It is a best example of running water. River system, while moving, it will create landforms into two types. One is erosional landform. The other one is depositional landform. The famous river here, Krishna, while it is flowing, it will erode some sediments along its course of flow and it will deposit at some places near its mouth. Is it right? Such erosional landforms, there are few terminologies you should know. You should know few terminologies in erosional landforms and also in depositional landforms. First, erosional landform. Splash, rill, gully. After this gully will expand and form a V-shaped valley. Have you seen any valleys? Any valley? Valleys? No. In the river flow, we will mention, for example, I think these two are Himalayas. Just for example, not only Himalaya is necessary, Himalayan mountain, two Himalayan mountain. Here we have snow. Snow in the top of Himalaya. When the snow melts, it will flow into river streams. When the snow melts, it will flow into river streams. These river streams falling in this region, we call it as valleys. Okay, valleys are nothing but river falling in V shape. Why this V shape is formed? Because they will erode the things in this steep slopes. They will erode the things in the steeper slopes along the mountains and form the valley region. Okay. The third major important erosional landform of running water is valleys. Okay. In valleys, we have two kinds. One is gorge, other one is canyon. Both of these are differences and all I will show in photo. Just understand valleys, we have two kinds. One is gorge and the other one is canyons. Okay. After formation of valleys, the river will not flow in the straight direction. Will the river flow in the straight direction? Will they flow straightly? No, they will form something called as meanders. They will. How is this looking? This is looking like a flow of snakes, right? This is looking like flow of snakes. This is called as meanders. Such flow. The flow where it will go like haphazardly, it is called as meanders. Meanders is one of the erosional landforms of the river. Okay. After meanders, when they enter planar regions, the river forms a terraces. In plains, they will not flow straightly. They will form something. I will show in photo and I will explain. This is difficult to write. They will form some terraces. These are called as paired terraces. Okay. These are few erosional landforms of running water or river. Okay. There are other minor things I will show in the photographs and I will explain. Later, we have depositional landforms. Roughly understand, this river will deposit the sediments it is carried from the mountains and other regions. It will deposit somewhere before draining into ocean. That is now, at that places we have depositional landforms. Depositional landforms, we have major thing known as alluvial fans. Alluvial fans are nothing but, imagine this is Ganga river. Ganga river draining to which sea? Ganga drains to which sea? Arabian Sea. Ganga river really drain ಆಗ್ತದೆ. Bay of Bengal or Arabian Sea? ವಿಶ್ವನಾಥ್ ಎರಡೇ ಇರೋದು ಆಪ್ಷನ್. ಒಂದ್ ಹೇಳ್ಬಿಡಿ, ನೀವು ಒಂದ್ ಹೇಳಿ ಅವರೊಂದ್ ಹೇಳಿ. Bay of Bengal. Ganga drains into Bay of Bengal. While Ganga draining into Bay of Bengal, it will deposit the sediment before draining. These sediments will look like a fan structure. These are known as alluvial fans. Okay, na? These are the fan-like depositions brought by the river are known as alluvial fans. Second important one is deltas. Deltas are same when they are entering the water or oceans. When the river is entering the ocean, they will form some creatures where the stream will go. This is the stream, this is the deposit. This is the stream and this is the deposit. A stream, a deposition. A stream, a deposition. This is called as deltaic region, deltas. And third major one, braided channels. Braided channels. Braided channels are nothing but when the river is flowing into oceanic regions, they doesn't flow in a single stream. They will form multiple distributaries. These distributaries, these river streams, looks like a girl's braid, which is nothing ಜಡೆ ಹೇಳ್ತೀವಲ್ಲ ಆ ತರ ಕಾಣಿಸುತ್ತೆ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ braided channels. These are depositional landforms. You should know something about erosional landforms. Which are the terms coming under erosional landforms? Which are the terms coming under depositional landforms? This is quite boring, but in Group C exams, they will ask questions. It is quite boring, no? Compared to mountain formation, plateau formation, this is quite boring. There are many terms coming in. Just know what are these terms. As I explained, when the water, when the precipitation occurs, when rain falls, after splash we have rills. Rills are nothing but this. We have seen this many times. Near the roadside, near your villages, in your farmlands, you have seen these small channels called as rills. Just mention landforms formed by running water. Landforms formed by running water. In that you just make two segments. One is erosional, one is depositional. Erosional landforms. Second one is depositional. Under erosion, you write rills, sorry, splash erosion you can. But it is not a landform. It is a type of erosion, but it is not a landform. Rill is a type of land. Rill. I think no need for definition for these and all. You can understand, no? Rill, gullies, valleys. Okay. In valley, we have two kinds. One is gorge, another one is canyon. Gorge, see, first understand, gorge and canyon, the difference can be a statement-based question in your exams. First one is gorge. Gorge has equal length in top and also in the bottom. Gorge has equal length both in top and at the bottom. Okay. Whereas canyon is wider at the top and narrow at the base. In this photograph, you can see this gorge has same width even in top and the bottom. The canyon is wider at the top and narrow at the base. This is a simple difference. Canyon has the sides which is step-like. In this, just imagine this photo, you can come across the definition also. Gorge is something which has similar width at top and bottom, whereas canyon wider at the top and narrow at the base, and it has steep steps like slopes along the sides. That is, just mention these two. Valleys are two types. One is gorge. Deep valley with straight sides. Straight sides. Straight sides. Canyon is a step-like sides. Step-like side with wide top, narrow bottom. Wide top, narrow bottom. Then one more thing you have, just understand this. Have you been to any waterfall? Which waterfall?
Us.
Sorry?
Us.
KAS. Waterfall? No waterfall. Haven't you visited any waterfall till now? No. Okay. Wonder of the world. Seriously, I have not visited any waterfall. Names, okay, then that is fine. At least you have visited waterfalls. Okay. Imagine this is the name you said, the KAS waterfall. When the water falls, it has pressure or not? It has some pressure or not? It has some pressure. While the water is falling with some pressure, it will form something like holes. Have you seen this? Under beneath the waterfall, we have some hole structures. This is called as pat holes. These holes are called as pat holes. There are several such small holes. Two or three such holes will join together in long run of time. After several years, these holes will join to form a pool-like structure. This will act as a pool and water gets filled. That is called as plunge pools. Pool. Similar to swimming pool, these are small pools. These are called as plunge pools. These are due to erosional activities of what is called as waterfall or a running water. Understood? What is the difference between pat hole and plunge flow? Pat hole is a single hole formed due to pressurized action of running water, whereas plunge pool is joining of two or more pat holes. Take down pat holes. Next type of erosional landform, pat hole erosion. After valleys, take down pat holes. These are small circular depressions. Small circular depressions. Next, take plunge pools. These are plunge pools. These are large depressions formed by joining two or more pat holes. By looking at this image, you can define both the terms, pat holes and plunge pools. See, here there are small pebbles collected. These pebbles will circulate also. When the water falls, this pressurized water circulate these small stones and it will create the larger pat holes. First, the pat hole will be smaller. Due to erosional activities between these stones, it will create larger pat holes. Later, pat holes join to form plunge pools. Just remember the terminology, it's more than sufficient. Then we have meanders. Meanders are nothing but the way your river system flows. When they are young, when the rivers are very young, they meander most. Young rivers meander the most, whereas older rivers, they flow less meandering. They flow just like this. Older rivers. Young rivers, they cross body themselves and form much more meander-like shapes. Next, erosional landforms, meanders. Just mention the name, meanders or incised meanders. Incised meanders. Because of the shape, they are called as incised meanders. In that, just write one word. These are loop-like channels. Loop-like channels. Okay. Next erosional landform of river is your terraces. First understand what are these terraces, then you can see when the water is flowing, when the river is flowing. Imagine there is a river coming from this side. The river is flowing while it is think it is summer. Now the season is summer. Do you think the flow of river is high or low? What do you think? The flow of river flow is very low. In summer, the river flow is still here. Okay. In rainy season, what happened to the river flow? It will increase or decrease? Yeah, it will increases. Till here. Such increase and decrease of river flow forms something called as some landform called as terraces. Increase and decrease of river flow form a new landform called as terraces. You can see this in your villages. Near the lakes, they say Kodi bidide, Kodi bidide. I have heard of this Kodi. Kodi bidide anta. ಮಳೆಗಾಲದಲ್ಲಿ ಕೋಡಿ ಬೀಳುತ್ತೆ. ಕೋಡಿ ಬಿದ್ದಾಗ the river flow is full. When the river flow is full, we don't see these terraces. When the river flow is less, we see these terraces very visible. When the terraces are symmetrical, when the terraces are symmetrical, when the slope this side and this side is equal, we say this as paired terraces. We call it as paired terraces. When the steps, length of steps this side and that side is not similar, we call it as unpaired terraces. Understand? Terraces is a found type of erosional landform. That's it, you should know. Okay, erosional landform. What are terraces? You can understand by drawing this image, a simple image. Just mention this word, river terraces, below the erosional landform. Okay, this completes erosional landforms of running water. Can you read? Okay, you can read. What are the erosional landforms of running water? Just name them. What you all written, the names. First one, rill, from there. Good. In valleys, we have two kinds. Okay. After that? Oh, plunge pools and meanders. Okay. Terraces. Just now I told you, terraces. These are the erosional landforms of running water. After this, we have depositional landforms. First important depositional landforms are alluvial fans. Alluvial fans. Just look at this diagram, you will get to know what is alluvial fans. Is this visible? The river is flowing and it is entering the ocean. Before entering the ocean, it will deposit all the mud, all the soil, all the sediments it has carried in the riverine mouth. This deposition looks like a fan. Since this soil is called alluvial soil, they are called as alluvial fans. Do you think the alluvial fans are fertile or not? Alluvial soils are very fertile because they are carrying the sediments from rivers. Rivers carry the rich sediments. These alluvial soils are very much fertile. Do you think the definition is needed for alluvial fans? You can understand, right? These are cone-shaped fans created by deposition of river. Then we have deltas. Deltas. Second depositional landform is delta. Where are these deltas formed? These deltas are found in the mouth of the river. Where these deltas are formed? River mouth alli form agutte. For example, This is our Ganga river system. Here, the Ganga river flow. Here we have Brahmaputra river system. They both drain into which? Bay of Bengal. This draining area, they will form deltas. In this draining area, we have triangular formation called as deltas. Deltas are formed at the mouth of river due to deposition, similar to alluvial fans. Alluvial fans are large one, whereas deltas are formed at very oftenly we can see deltas large rather than alluvial fans. Deltas are small triangular shaped creatures formed due to deposition of sediments by the running water. The coarse material will settle first and the finer particles will settle at the later stages. Then we have floodplains and natural levees. Okay. Just understand what are these floodplains and natural levees. Oh. This is river flow, okay? When river is flowing, during its flooding season, during the rainy season, the river has increased its volume. Is this right? River volume will increase and it will flow alongside the bank. Both the sides, it will split over alongside both the banks and it will form something called as floodplains. The plains formed in these regions are called as floodplains. When is this seen? Floodplains, when are floodplains formed? During heavy flow or monsoonal season. We find this floodplains. Natural levees are nothing but during the formation of floodplains, the sediments are deposited in certain fashion. Like crust and trough ತರ ಇರುತ್ತೆ ಫ್ಯಾಷನ್ ಅಲ್ಲಿ ಸೆಡಿಮೆಂಟ್ಸ್ ಡೆಪಾಸಿಟ್ ಆಗಿರುತ್ತೆ. These are called as natural levees. Natural levee. Okay na? These two are the depositional landform of river flow. Just mention the name floodplains. In your advanced courses, you will get the detailed definition and all. Just know it is a depositional landform, floodplain and natural levee. Okay. Now, okay, this is quite interesting now. Oxbow lakes. Oxbow lakes. Just understand how oxbow lakes are formed. What is this flow of water called as? Good. This is called as meanders. Okay. During high intense flow, these meanders when the curve is near, they will spread out and find the shortest route. The water has to travel along this course, no, which is quite long distance. They will find a short distance and they will cut this off. It will be cut off after maturation. Young rivers travel more distance. After maturity, when the river gets older, they will cut off these paths, this path, and they will see a flow in straight line. While cutting off this part, the river flow now has changed its course into this one. The course, the part which is being cut off from the main river stream is called as oxbow lake. Since it looks like a bow of an ox ಕೊಂಬು ಕೊಂಬು ತರ ಕಾಣಿಸುತ್ತಲ್ವಾ, this lake is called as oxbow lake. Oxbow lake is a depositional landform of river because some sediments get deposited at this junction. It will separate the lake from the main stream. It will form a new landform called as oxbow lake. Oxbow lake is formed from which kind? It formed from meanders. Okay. Mention Oxbow lakes. Depositional landform, Oxbow lake. Then last, braided channels. Braided channels are nothing but when the river is entering into ocean, we have many channels forming like a gulf's braid, which is known as braided channel. It is a deposition because the sediments are deposited in between the braids. This is the sediment deposition areas. It looks like braids. That's why braided channel. Just mention the name. It is a depositional landform. Okay. Thus, that completes your running water, depositional and erosional landforms. You can read the depositional landforms.
Things naturally also lakes related.
Okay. Just know these names. That's enough. Okay. Then we have groundwater. In groundwater also, you just make two divisions. One is erosional. The other one is depositional. Where do we found groundwater collected? What is the place where the groundwater is collected? A place na ಏನಂತ ಕರಿತೀವಿ? ಗ್ರೌಂಡ್ ವಾಟರ್ ಎಲ್ಲಿ ನೋಡ್ತೀವಲ್ಲ ಆ ಪ್ಲೇಸ್ ನ ಏನಂತ ಕರಿತೀವಿ? ಭೂಮಿಯ ಕೆಳಗೆ ಎಲ್ಲೋ ಒಂದ್ ಹತ್ರ ಗ್ರೌಂಡ್ ವಾಟರ್ ಇರುತ್ತೆ. What is that place called as? Groundwater is collected at certain places called as aquifers. Aquifers. These are reservoirs of groundwater. Mention this. Aquifers are the reservoirs of groundwater. AQUIFERS are the reservoirs of groundwater. Groundwater is collected in aquifers. Oh. Similar to your running water, groundwater will also form some features which are these are the aquifers. Okay? In this we have groundwater. This groundwater will react, this water will react with the stone surrounding it. This, there are many stones here, right? The stones surrounding the aquifers will undergo some chemical changes and form major landforms. Okay. What are the chemical changes they will undergo? It is water, right? It is water. These are rocks. They will undergo changes like hydration, oxidation, carbonation, and other redox reactions. They will undergo various chemical changes, and we see something like eroded holes in these rocks. Eroded holes in these rocks. These are similar to your path holes and plunge holes. Okay. First is erosion. Erosion will create nothing but holes. Then when these holes, imagine there is a hole in this rock which will increase its structure. hole will increase, and it will go deep into the rock. It will move inwards, and it will form something called as structure called as caves. Is this clear? Erosion. There nothing but water is eroding this rock, and it will creating some cavity known as caves. Cave is an erosional landform, running water. Then just learn this. Then you have something. Look, there is erosion happening in this rock also, in this rock also. There is something eroded and creating the hole here. Here also hole. The remaining one will form a creatures, a structures. In photograph, you will get to know clearly. The remaining thing, here also hole, here also hole. The remaining thing, uneroded thing, forms something called as stalagmite and stalagmite. These are nothing but uneroded things. And also this soil also contains, this water is also contains some amount of salts and sediments, right? Any water contains some salts. These salts will deposit on that stalagmite and stalagmites, forming a depositional landform called as stalagmite and stalagmite. Understand? What is these depositional landforms? The salt will get deposited on the uneroded material, uneroded rock, forming stalagmites and stalagmites. When these stalagmites and stalagmites join together, they form a structure called as pillars. Pillars. Next one is pillars. These are the major landforms of groundwater. Just look at this image. Caves you have understood, I think. This is the cave. Okay. First, this is the cave. The upward one is called stalagmite and the lower one is called stalagmite. When these two joins, they form something called pillars. These are the pillars. In this image, you can see, here also you can see, when these both are joined, they form pillars. This is called stalagmite and the downward. Here you can see this is stalagmite. Okay, clear? These are the depositional landforms. Just take down the names, that's enough. Groundwater. First one, erosional sinkholes. Sinkholes are nothing but same like your pathholes. Sinkholes. Next one is caves. Erosional landform, sinkholes, caves. And another one name is collapsed sink. Collapsed sink is nothing but your plunge pool. Similar to your plunge pool, collapsed sink. Sinkhole, collapsed sink, and caves. Then depositional landforms. You will write stalactite, stalagmites, and third one, pillars or columns. Stalactites, stalagmites, and pillars or columns. Just mention this diagram also. Just to know this difference, stalactites is the one which is present in the upper portion. Stalagmites something which is from lower one. Stalactite, stalagmite. Pillar joining both. You mentioned that wrong. See, stalactite is something in the cave. When the deposition happens in upward portion, what we call the ceiling of the cave, when the deposition happens, it is called as stalactite. In the floor of the cave, when the deposition happens and builds some structures, it is called as stalagmite. Inside the cave, this is happening. In the floor, it is called as stalagmite. In the ceiling, it is called as stalactite. Then glaciers. Glaciers. Do you think glaciers are heavy or lighter one? Heavy or lighter one? Glaciers. Heavy. Glaciers are solids. These are ice crystals, ice in solid state, and these are massive. These are not like ice cubes. They are massive ones. These are mass of ice moving under its own weight. These are glaciers are heavy in weight. They form many landform features. For example, first one is erosional landforms. Erosional landforms. Just learn from this image. Imagine this is the top of Himalayas. Okay, Himalayan top. Here we have glaciers, many glaciers. When they move, sudden movement of such glaciers will form something like steeps. These are called as silks. Silks are Kori silks. These steeps are called as silks or Koris. And these glaciers, when they fall, they will melt in some depressions. Such depressions, they will form torn lakes. In some depression, they will melt and form torn lakes. Okay. First erosional landform of glacier is silks. Mention. Erosional landform of glacier. Cirque. Cirque. Just mention two lines. These are deep, long, wide, long, wide basins with very steep, wide basins with very steep, concave to vertically dropping high walls. Concave to vertically dropping high walls. Just in this photo, you can imagine what are silks. For definition purpose, these are very steep, concave to vertically dropping high walls. These are silks. These high walls are called silks. Then we have fjords. Just understand it is 2024 UPSC mains question. Fjords. This is Himalayan region. We have glaciers here. When the glaciers move, when the glaciers move, they will carry huge amount of mass along with them. When they move, they will form a steep like slopes. This is called as valleys. In normal rivers, we have valleys. Similar to valleys, when the glaciers move, they form a beautiful fjords. They form beautiful fjords. There is image. Oh, this is U-shaped valley or also called as hanging valley or forts or F is silent fjords. These are beautiful. Scenic beauty is importance of these fjords. These are not V-shapes as our running water. These are U-shaped fjords. Problem? No. These are U-shaped fjords. Mention erosional landform. Second one, fjords. First one is cirque. Second one is fjords. Fjords are very steep, U-shaped valleys. U-shaped valleys. Then you have ons and errats. Just think, when the glaciers will move, here is a glacier, this side is also a glacier, Just imagine a 3D structure of a mountain top. When you imagine the 3D structure of mountain top, you have glaciers all the sides. All the sides you have glaciers. When all the sides the glacier will downfall, they will erode enormously, isn't it? They will erode enormously and forming a sharp top. These are called as horns. These tops are called as horns, formed by erosion of glaciers. Glaciers erosion will cause horns. In this image, you can see the glacier are eroded from this side also, this side also. They're forming a steep peaks called as horns. Then you have depositional landforms of glaciers. Glaciers are similar to your river system. This is glacier. Below glaciers also we have numerous amount of sediments. Sediments includes what may be the sediments of glacier. What all the sediments that consist below the glaciers. What might be that? ಏನಿರ್ಬೋದು sediments glaciers ಕೆಳಗೆ? Good. Small rocks. Then few soil particles ಇರಲ್ವಾ? Soil particles. Then ಕೆಲವೊಂದು dead and decayed material. Okay, these are the sediments contained below the glaciers. When glaciers move, they will carry these sediments along with them. These sediments, like small rocks, in glaciers, we use the term for them as moraines. What is the term we use? These are called as moraines. See, depositional landforms, these moraines get deposited at two different places. One is along the lateral or the periphery of movement of glaciers. Along the periphery movement of glaciers, these are called as lateral moraines. These are called as lateral moraines. Along the periphery, this is the glacier's movement, and along the sides we have lateral moraine. In the middle, we have something called medial moraine. Middle region, because of its depression in the middle also, the sediments will get deposited. It is called as medial moraine. Just mention the names: lateral moraine, depositional landforms, lateral moraines, medial moraines, middle one, medial moraines. Okay. Then we have eskers. Eskers. Let's understand what are these eskers. Eskers are nothing but when the glacier is already melted. Glaciers are already melted in summers. Eskers are seen during summer seasons. When glaciers are melted, the deposits, beneath the glaciers we have many rock particles, soil and small rocks. These form some ridge-like structure, some mountain-like structure. These ridges are nothing but eskers. When we see these eskers during summer season, when glaciers melt in summer, we see something which is raised upraised platform, which looks like upraised platform. Here the black one. The black is something called as sediment brought by the glacier, which looks like a ridge, a small hilltop. It is called eskers. Mention eskers seen in summer season. Seen in summer season when glaciers melt. Glaciers melt and sediments and sediments are deposited in the form of ridges. You should know this word. It is similar to a ridge. Next one is glacier. When the glacier flows, imagine there is a large amount of glacier. When it is flowing, it will leave some structure known as drum line. It is same to like your in wind erosion, you will see this barchans. In desert areas, you will see something like this creatures, no? In desert areas, somewhere we have dooms and somewhere we have tail end. When the glacier moves, one side it has steeply eroded and the other side is not much steeply eroded. This is called drum line. Drum line is nothing but a depositional landform of glacier. Drum line, smooth oval shaped ridge like structure. Drum line, smooth oval shaped. This is like half oval, oval shaped ridge like structure. It is draining, right? It is too much draining. Draining in the sense you are getting like extra energy draining of yourselves. Then we have last one, wind. Just I will take 5 minutes, okay? I just mention the names, that's enough. Wind we can understand easily. Landform features formed by wind. First one is erosional landform. In that erosional landform, erosional and deposition, similar. Just understand, we are in Rajasthan now. Where are we? In Rajasthan deserts. Which is the famous hill in Rajasthan? As we discussed residual mountains, I mentioned about a hill known as Aravalli. Aravalli is the hill which is seen in Rajasthan, like desert area. When this Aravalli come across large quantity of air, large quantity of wind blowing into the Aravallis, what will it do? Will it erode or not? It will not erode. Not erode. Yeah, it will erode its soil. Soils of Aravalli hills will get eroded and it will get deposited at some places. Soil get eroded and placed at some other place due to erosional activity of wind. Such erosional activity of wind form a new landform called as peneplain. These peneplains are nothing but planar regions. Peneplains are nothing but planar regions formed by erosion of wind. Have you understand how this is peneplain formed? Due to erosion of previously existing landform will get eroded and it will deposited into flat plains known as peneplains. Okay. In deserts, you will see some structures like small rocks. In Rajasthan, you will see some small rocks here and there in Rajasthan. When wind erodes, when wind will come, it will have enormous amount of energy. The wind will carry enormous amount of energy. It will erode the baseline. ಎಲ್ಲಿ ವಿಂಡ್ ತುಂಬಾ ಜೋರಾಗಿ ಬರ್ತಿರುತ್ತೋ ಅಲ್ಲಿ ನಾವು ಎರೋಷನ್ಸ್ ನ ನೋಡ್ತೀವಿ. ಎರೋಷನ್ಸ್ ಆಗಿ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನ್ಯಾರೋ ಆಗುತ್ತೆ, ಟಾಪ್ ಏನಾಗುತ್ತೆ, ವೈಡ್ ಆಗಿರುತ್ತೆ. Here it is having narrow base, top is wide. it will form a new type of rock. This rock, how it's looking? It is looking like mushroom. As the rock is called mushroom. First one, erosional landform cell. First one is pediplains. Second one is your mushroom rocks. This is mushroom. Actually, half of the photo has been cut. This is the top. In the bottom, we have something which is narrow. It looks like this. Mushroom rocks are mushroom tables. Then depositional landforms. Wind will carry enormous amount of sand and it will get deposit in the form of dunes. The shape is known as sand dunes in the form of dunes. In Rajasthan or Arabia, we have something like this. These are called as sand dunes. Sand dunes. Sand dunes. The shape, if the sand dunes shape is crescent shape is nothing but half moon shape. It is called barchans. Sand dunes, barchans, or the depositional landforms of wind. Sand dunes, second one barchans. If the crescent shape is not full, if it is half crescent, then it is called seif. Seif, S-E-I-F. Seif. Last one, loess. Loess. These are nothing but silt deposited due to erosional activity of loess. Okay, this completes major landform features. Okay. Artha aita? I've understood. Huh? Anything? It might be quite speed because they have given less time and more syllabus. We have to speed up for some areas. Okay, questions. Try to solve this. It is actually not been explained by me. Just you have to know that. I will help you out. So try to guess an answer. Cast. Rose? Cast. Okay, good. You have guessed it right. Cast topography is something formed due to limestone. When the base is limestone, when it get eroded, it will form cast topography. The best example for cast topography is the film Madakari film. Have you seen Madakari film? There they have shown beautiful cast topography. Just Google itself. You just Google this name, cast topography. You will find beautiful image. It looks similar to underground erosional and depositional images which I have shown. Underground activities, underground water. In that, what we have seen, the same limestone and dolomite will react with underground water, forming cast topography. Okay. The formation of river delta is the result of which process? Deltas are formed due to erosion or deposition? Deposition. Which of the following is a typical feature of river erosion in its youthful stage? Gorge, cut bank, oxbow lake, natural levee. Think. Youthful stage. That's why actually oxbow lake is a depositional landform. While explaining oxbow lake, I have said it will get deposited here and cut off and the remaining will form oxbow. This is actually a depositional landforms. They are speaking about erosional landforms. Be specific about the words. Which of the following is a type of channel pattern? Meanders, barchan, trellis, Khadar. Channel country. Channels, actually it comes in river system. Meanders. The groundwater stored between the layers of hard rock below the water table is called glaciers, hot springs, geysers, aquifers. They are speaking about groundwater stored inside the ground. Aquifers. Aquifers. It is the reservoir of groundwater. Ural Mountains in Russia are which type of mountain? Whether it is the old fold mountain, young fold mountain, block or volcanic mountain. Ural Mountains. Have you read about this mountain? Ural Mountain. It is found in Russia. It is a natural divide between Europe and Asia. Which is which type of mountain? The question will be in the same pattern. Old or block, young or old. Take a guess. It may be right or wrong. Old fold mountain. Yours? Take another guess. Young, block, old fold mountain. Ural is actually a old fold mountain. But our Himalayas is, it is a fold mountain, but young fold mountain. Himalayas is young fold mountain. Okay. Any doubts?